Hartzell Propeller leads the industry in composite blade technology. Our composite blades are lightweight, durable, and engineered for cutting-edge performance. Unlike aluminum or wooden blades, they can be restored to their new dimensions over and over again. They're surprisingly easy to repair. This video demonstrates repairs made to a Kevlar or Kevlar carbon hybrid blade, specifically on damage to the trailing edge foam region of the blade. For purposes of demonstration, the blade shown in this video is the Hartzell N7605K. Before you begin your repair, you can find your specific blade model on a sticker on the cylinder of the propeller. For some earlier composites, that sticker will be on the blade. If the blade model isn't obviously identifiable, just check for it on the inspection sheet that came with your prop. Your specific blade model will be identified by the characters after the slash. Hartzell Technical Representative Kevin Ryan has taught countless classes around the globe about the intricacies of composite propeller repair. Today, he'll teach you.
Hi, before we get started, let's look at some of the materials and tools we're going to need to perform a repair on a Kevlar or a Kevlar carbon hybrid blade. You'll need a coin tapper, a sanding block, and some sandpaper. The repair materials, e-glass, fiberglass. You'll need clean rags, clean lint-free rags. Don't ever use one of these commercially available shop rags. They have oil in them and they'll damage your repair. In this case, we're using cheesecloth. You'll need a marker, Sharpie, a steel straight edge, a piece of 20,000 safety wire, some vacuum bag material, the repair adhesive, a tape measure, scissors, some acid brushes, a grinding or sanding tool like this Dremel or a die grinder, some clamps, C-clamps, some spreader plates, some solvent. This could either be MEK or acetone or denatured alcohol. The appropriate colors of touch-up paint. A DA sander can come in very helpful post-repair. Some tape, and let's not forget your personal safety equipment, dust mask, and a pair of safety glasses.
Before beginning any repair, you'll need to reference the Hartzell Composite Propeller Blade Field Maintenance and Minor Repair Manual. It's more simply identified as Hartzell Manual 170. You'll find Manual 170 on our website. Just type in hartzellprop.com/Manual 170 and the PDF document will download to your computer. Once Manual 170 is open, first click on the chapter entitled Inspection Procedures in the left margin. Under the list of figures, find the link that identifies your prop. In this case, since we have an N7605K blade, we know it's listed as an N-shank blade. Click on figure 1.3. Here, you'll see a graphic of your blade. In order to properly assess this particular damage and determine whether your prop is within the airworthy limits of repair, we need to determine whether the damage is on the trailing edge foam region of the blade. You'll see that distance Y is the distance from the tip of the blade to the end of the trailing edge foam region. You can see by the chart for the blade that we're working on, the N7605 blade, that difference is 24 inches. Let's take a look at the blade now.
We'll measure from the tip to the outboard edge of the damage, and we can see that that damage is approximately 16 3/4 inches from the tip, which puts us squarely in the trailing edge foam region. So we'll need to assess that damage and repair procedure in the chart.
When you return to the manual, navigate to the chapter called Damage Evaluation. When you click on that title in the left margin, you'll see a list come up of nearly 36 kinds of repair. Our type of damage is a crushed or cracked trailing edge foam region. In this case, number 32 on the list. Click on the link and you'll see this chart. Locate the model N7605 on the vertical grid and follow it down to the horizontal grid for line 32. You'll see the X where line 32 intersects with the 7605 blade is line 32 limits 1. Again, follow the proper links, and you will eventually end up at this table. That will tell you whether your damage falls within the airworthy limits of the prop. You'll see on this table that the airworthy damage limits for this kind of damage is a 1/4 inch depth and 2 inches in length. The maximum permitted depth of a crushed or cracked area is 3/8 of an inch. The maximum permitted length of a crushed or cracked area material is 2 inches. And the manual here directs you to the repair details in section 5E. You can find 5E in the minor repairs navigation on the left, and you'll find the same instructions for the repair there that we'll explain in this video. One thing to note here is that the airworthy damage limits are a 1/4 inch depth and 2 inches in length, but we can repair up to 3/8 of an inch in depth and 2 inches in length. So in this case, the airworthy damage limits are less than the minor repair specs. Now, if your damage exceeds these dimensions, you'll need to see a propeller shop or contact us here at Hartzell.
In order to properly assess this damage, I'm going to need to remove some of the surrounding paint to determine how far that area has been crushed or cracked. Once again, I use the sanding block and the 80 grit sandpaper to remove the paint in the area. In this case, I'm going to also have to remove the paint from the face side of the blade because the crack or crushed area is on both sides of the blade. Now that I've got the area sanded, I'm going to wipe the area off with solvent. You can use denatured alcohol, MEK, or acetone. To assess the damage, I'm going to coin tap the area. I'm using a heavy coin, in this case it's a bearing, and I'm just going to tap the area. What you want to do is start in an area adjacent to the damage so you can hear what the sound part of the blade sounds like, and then you'll be able to tell when the tone changes as you pass over the damaged area. So my damage is beginning right around here. And let's see how deep it is. Well, it's not very deep at all. So let's assess the airworthiness and repairability of this damage. To be within airworthy limits, the maximum depth of the damage is a 1/4 inch, and the maximum length is 2 inches. Well, we can see that this damage is only a little bit more than 1/2 inch in length, and it's less than a 1/4 inch in depth. So this is well within the airworthiness limits and well within the repairable limits on this blade. On this repair here, this damage goes to both sides of the blade. So what I'm going to do is I'm going to remove this damaged piece right here in the blue area, or what's delineated by the blue. I'm going to remove that material, and then I'm going to bevel out about 1/2 inch around it. To perform this repair, I'm going to place a piece of vacuum bag over the area, and I'm going to trace the area. I'm going to trace the area of where I tapered in for the repair, and then I'm going to trace out the area where I removed the material. I can then use this as a template to cut out my repair materials. You want to cut out your repair materials prior to mixing the adhesive. This is especially important if you have multiple areas on the blade that need repair. The adhesive has a fairly short pot life, about an hour, so you need to have all your repair materials cut out prior to performing the repairs so that you have the maximum time to work with that adhesive. All right, I'm going to use this template to cut out the repair material to repair the trailing edge foam region on the blade, on the N7605 blade. Before I cut this out, I'm going to make some parallel lines on the repair material. And this is so when I go to do the layup, I want to make sure that my material, that my layers of material are roughly at a 45-degree angle to each other. So I'm going to lay the one piece on here, and I'm just going to hold it and cut it out. Now I laid this first piece on the long way, so I'm going to turn this to the side about 45 degrees or thereabouts, and then I'll cut that center. And there are the two repair materials for that particular damage. This is the adhesive we're going to use to effect the repairs. The adhesive is mixed by weight. It's 100 parts of part A to 33 parts of part B. Once again, it's mixed by weight. This is a quart kit. This is what we buy at Hartzell that we use for production. There are also smaller quantities of this available commercially. You can get what they call a 50-gram pudding cup. Those parts are already pre-measured. You can just dump the one cup into the other. There's also an Easy Pack. The Easy Pack is 2 packages separated by a plastic separator. You pull the separator apart and you can mix the material in the bag. So if you're going to just do some small repairs, quart kit's probably overkill. Buy some of the pudding cups or the Easy Packs.
You may notice throughout this video that other parts of the propeller blade will be shown in various stages of repair, like this and this. That's because this video was taken over a period of time when we were also creating videos for other blade repairs on 2 other sections of the blade. Of course, none of this affects the repair that we're focusing on here. It's just a simple note for your reference as we continue through the repair process.
Prior to performing this repair, once again, I want to tack off the area with my alcohol. Make sure that all the dust from the sanding, any maybe oil from my hands or whatever have been removed. I'll take the adhesive and I'm going to apply adhesive all over the repair area and the outside of the repair area as well. Now this repair actually gets performed on both sides of the blade because the whole edge was damaged, so I need to apply adhesive to this side as well. Now this repair is a little tricky to perform. I'm going to take my first repair piece and I'm going to apply it on the back side of the blade. Then I'll saturate it. And I'll take my second piece and apply this one on the back side of the blade, and I'll saturate it. Now I can only do the bottom side of this at this point in time. Then I'm going to fold those materials over the top. Now, if for some reason or another I had to do an uneven repair, in other words, I went down more layers on one side than I had on the other, I could add an additional piece on the side that required it. So these particular repairs, when you fold it over, they move. And so sometimes you have to readjust them, like I'm doing now, so the whole area gets covered. My repair worked down this way. I'll take a piece of this fiberglass material. This is thin fiberglass material. This is not the same material that I used for the repair. I'm just going to cover the repair with that material. And what this fiberglass material does is it becomes a sacrificial layer when we go to sand. And almost all of this will get sanded off. And all it does is serve to blend the repaired area into the remainder of the blade. Then I'm going to cover this with some vacuum bag material. And then I'm going to cover that repair with two semi-rigid plates. This is masonite. You can use almost any sort of semi-rigid material. I taped these two pieces together so when I clamp it, the pieces sometimes will walk toward the trail edge of the blade, or sometimes they'll pull in and they can damage your repair. So I have that piece of tape there to keep everything flat. Clamp down on them firmly, and I'm going to keep the clamps off the immediate repaired area. I'm just going to work to the outside of them. The adhesive is cured. It takes 12 hours for the adhesive to cure at room temperature. So now we're going to remove the clamps and the spreader plates and see how our repairs look. That looks pretty good. I'm going to sand the repaired area on this trailing edge foam repaired area. You'll notice that some of this material is still was unwetted by the adhesive. That's not a concern. This was put on to be a sacrificial layer, and most of this will get sanded off anyway. You'll see when I begin to sand, most of this unwetted area will just fly off immediately. There again, no reason for concern. This particular repair went from both sides of the blade, so I'll have to sand both sides of the blades to check to finish the repair. I'm going to use a sander with 150 grit sandpaper, and then as I get near the end of the sanding with the sander, I'll switch over to hand sanding. So I'll get started. Switch over to hand sanding again. Once again, I'm using 150 grit paper. As you can see, we've done 2 repairs here. But even if we only did this one or this one, when we went to paint it, aesthetically, it wouldn't look very good to spot paint it. Now, there's nothing that says you can't. You'll still be protecting the blade will still be airworthy, it just won't look very good. So what we've decided to do is we're just going to scuff up the remainder of this blade, and we'll spray the whole side. I'm going to use 400 grit sandpaper, and I'm just going to lightly scuff the area to be painted. I'd suggest if your shop finds that they're doing a lot of this kind of work, your best option might be to go to the local vocational school, find a high school kid that's majoring in auto body repair, and tell them you don't want to work in an auto body shop, you want to work in the wonderful world of aviation. While I'm cleaning the blade, notice that I've masked off the tip stripes, the leading edge of the blade, the de-ice boot or anti-ice boot, if they're installed. If the blade doesn't have a de-ice boot or an anti-ice boot installed, it should have some erosion tape installed in this area. And if there's the erosion tape installed, you'll need to mask that as well. So now we're ready to paint. Once again, I'm going to use the touch-up spray paint. You wouldn't necessarily have to use the touch-up spray paint that's in a can. You could use the paint that we specify for the blades when they're new or when they're overhauled. This is paint that's canned up for Hartzell, but there's also a commercial product that's also in a spray can that's available for sale that you could purchase on the internet. All those part numbers are in our manuals. This paint won't look terrific, especially in the areas where I've done the repairs. It's going to take multiple passes. So we'll wait for this to dry. We'll give it another coat, and eventually it should look pretty good. Thanks for watching this video. I hope it's done something to dispel some of the fears you may have had about working on composite bladed propellers. As you can see, the repairs aren't particularly difficult, and with a little bit of practice, you can perform them in your shop. And if you happen to run into trouble, you can always give us a call here at Hartzell or send us an email. Thanks again for watching.
For more information about Hartzell composite propeller repairs, we invite you to contact Hartzell Product Support. Call 800-942-7767 and then option number 3. Or visit us online at hartzellprop.com.